Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET, Jest, Tifr, IIT-Jam and other exams related to physical science. And also guys, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes which are going to help you to crack the exams related to physical science. Okay, so this is the third part of this series of CSIR net physics PYQ of December 2019. Okay, so this is the third part of the series, and I'm going to start with first question now. Okay, so the question is a mole of gas a mole of gas a mole of gas a mole of gas at initial temperature at initial at initial at initial temperature Ti comes to comes to contact with comes to comes into contact with comes into comes into contact with comes into contact with a heat reservoir a heat reservoir a heat a heat reservoir at temperature Tf, and the system is allowed to reach is allowed to reach is allowed to reach equilibrium equilibrium allowed to reach equilibrium at constant volume at constant volume if the specific heat of the gas if the specific 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 heat of the gas if specific heat of the gas is Cv equal to alpha T, where alpha is constant, alpha is a constant, alpha is a constant, the total change in entropy, the total change, in entropy, is option A 0, option B alpha Tf minus Ti, plus alpha upon 2Tf into Tf minus Ti whole square. Option C is alpha Tf minus Ti, alpha Tf minus Ti, and option D is alpha Tf minus Ti, alpha Tf minus Ti plus alpha upon 2Tf into Tf square minus Ti square okay. So this is the one. So I'm going to solve it. So a mole of gas, so 1 mole of gas at initial temperature, so system of 1 mole of gas as initial the temperature of initial temperature of that system of 1 mole of gas is Ti, okay, comes into contact with a heat reservoir. So that comes in contact with heat reservoir which is at temperature Tf, okay, and the system is allowed to reach equilibrium at constant volume. So system is allowed to reach at equilibrium keeping volume constant, okay. If the specific heat of the gas Cv equal to alpha T, okay, that is the specific heat is given Cv equal to alpha T, where alpha is a constant, the total change in entropy you need to find out, okay, total change of entropy you need to find out, okay, delta S. Well, I'm going to solve it now. So first we'll find change in entropy of gas and then change in entropy of reservoir, because we need to find out total change in entropy, okay. So change in entropy of gas. So change in entropy, change in entropy, change in entropy, change in entropy of the gas, change in entropy of gas, okay. So we'll use the first law of thermodynamics, right? This is going to be TdS is going to be equal to du plus Tdv, right? This we know, and since we know volume is constant, right? So that goes into equilibrium at constant volume. So since volume is constant, that implies dv equal to 0. So this is going to be TdS equal to du, and value of du we know, right? Du is Cv dt, right? And Cv value is given, that is alpha t dt. So we'll put value here. So this is going to be TdS equal to alpha t dt, okay. So tt will get cancelled, so ds is going to be alpha dt, right? Or we can write delta S, that is change in entropy of gas, is going to be alpha Tf minus Ti, okay, alpha Tf minus Ti, equation number 1, okay. Now we need to find change in entropy of reservoir, which is at constant temperature Tf, okay. So change in entropy of reservoir, change in entropy of reservoir change in entropy of reservoir, that is at constant temperature, okay, Tf. So change in entropy of reservoir is going to be this one, from here, this one, right? This T TFDS equal to uh, TFDS equal to alpha T dt, this equation, okay? This is, you can say 1, this is 2, okay? So so change in entropy of reservoir is going to be, so reservoir is going to be this one, TFDS is going to be uh, alpha T dt, okay? So from here TFDS is going to be uh, alpha T dt, right? This is alpha T dt, alpha T dt, okay? Alpha T dt. So from here we can write TF into change in entropy of reservoir. Change in entropy of reservoir. This is going to be alpha T into Ti, T at Ti upon Tf, okay? T square by 2. So dt is going to be, will differentiate, right? So alpha T square by 2 from Ti to Tf, okay? So this is change in entropy of gas, change in entropy of reservoir is this, okay? So TFDS equal to alpha D dt. We'll use first law of thermodynamics here as well, okay? So this one TFDS is TFDS is going to be alpha T dt, okay? Well, so now this is going to be TF delta S reservoir, that is entropy of reservoir is going to be uh, alpha by 2. This is going to be TF square minus Ti square, okay? Or we can find, or then T, then delta S reservoir is going to be, that is entropy of reservoir is going to be alpha upon 2 TF square minus Ti square, okay? This one TF square minus Ti square, okay? So now total entropy is going to be, change in total entropy we need to find out, right? Change in total change in entropy. So total change in entropy delta S is going to be delta S gas plus delta S reservoir, okay? So this is going to be um, this is this one, right? For entropy of this is alpha Ti over Tf minus Ti, alpha Tf minus Ti plus this alpha upon 2 Tf square minus Ti square, okay? Tf square minus Ti square. Okay, so which option is matching? Option D is the correct one, okay? Option D. So this is alpha Tf minus Ti plus alpha upon 2 Tfi into Tf square minus Ti square. So this is the answer, guys, okay? Total entropy, okay? Very simple question, right? So next question is question number 2. Very simple question, formula based question, okay? An ideal Carnot engine, an ideal and an ideal Carnot engine, an ideal Carnot engine, an ideal Carnot engine extracts 100 joule. An ideal Carnot engine extracts 100 joule from a heat source, from a heat source, and dumps dumps and dumps 40 joule to a sink, to a heat sink, to a heat sink, to a heat sink at 300 Kelvin. Okay, so 40 joule is dumped by the Carnot engine. Okay, at 300 Kelvin, the temperature of the heat source is the temperature the temperature of the heat source temperature of the heat source is, okay, options are option A 600 Kelvin, option B is 700 Kelvin, option C is 750 Kelvin, and option D is 650 Kelvin, okay. So this is the question, very simple formula based question. An ideal Carnot engine extract 100 joule. So ideal Carnot engine extracts heat of 100 joule from the heat source, okay, and dumps 40 joule to the heat sink, okay, at which is at heat sink is at 300 Kelvin temperature, okay, and the temperature of heat source we need to find out, okay. So we can easily solve it by formula. There is a formula for second law of thermodynamics, that is Q1 upon Q2 equal to T1 upon T2, okay. So this is that heat ratio of heat equal to ratio of temperature, okay. So Q1 is given, that is 100 joule. So 100 joule upon Q2 is given, Q2 is 40 joule, okay, 40 joule, and T1 is given. The T1 we need to find out the temperature of heat source, and T2 is given, T2 is 300 Kelvin, okay, simple. So now from here we that implies value of T1 is going to be 100 into 300 upon 40, and that is going to be 750 Kelvin. 750 Kelvin. This is the value of T1, that is temperature. So so the heat source, the temperature of heat source is 750 Kelvin. So which option is matching? Option C is matching, guys. Okay, option C, 750. Well, next question. Very good questions. Okay. Next question. Question number 3rd. Question number 3rd. Question number 3rd is a block of mass m. A block of mass m attached to a spring to a spring, attached to a spring, attached to a spring, oscillates horizontally, oscillates horizontally, oscillates horizontally on a surface, on a surface, on a surface. The coefficient of friction, the coefficient of friction, coefficient of friction between the block, between the block, between the block and the surface, and the surface, and the surface is mu, is mu. Which of the following trajectories, which of the following, which of the following trajectories which of the following trajectories which of the following trajectories best describes, best describes, best describes the motion of the block, the motion of the block, the motion of the block in the phase space, in the phase space, in the phase space, that is XPX plane. Okay, XPX plane, and diagram is given. This is the surface and this is the spring, and block is attached with it. Okay, horizontally it's oscillating. Okay, block M, and options are, so we have to find we have to select the uh, correct trajectory. Okay, so the first one is, this comes like this. Okay, so this is one, this is X, and this is Px. Okay, it starts from here and then getting increased. Okay, option B is trajectory of the motion of block, motion of the block. Okay, option C is ellipsoidal. Clockwise. Option D is anti-clockwise. X, Px. Okay, so this is the question, guys. So question is very simple. A block of mass m attached to a spring oscillates horizontally. Okay, so that block is oscillating horizontally like this on a surface, horizontal surface. The coefficient of friction between block and surface is, the coefficient of friction is mu, right? So it means there is a fact. The correct option that which describes the motion of block. in the free space. Okay, so from here you can see. So I will write some point as well. So we can see friction, due to friction, because there is friction coefficient between surface and block, right? So that means there is a friction, right? Due to friction, amplitude and momentum, amplitude and momentum of oscillation continuously decreases. Okay, continuously decreases. Okay, so which option is going to be here? You can see block is this motion is going here, and then it is keep increasing, right? So this graph is not correct. If you talk about this the graph is moving in elliptical path. So means this graph this block will never come into the rest, right? Which is not possible, because it will come into the rest because there is a friction working. Similarly here it is in elliptical path. The motion of particle or motion of block is in elliptical path, right? In elliptical path and anti-clockwise, it means it will remain in elliptical path, right? And it shows that the motion of the block is not going to be at rest at never going to be going to be rest, right? So it will not come at rest. So these three graphs are incorrect, right? So this is the correct graph, guys. Here you can see particle is moving from here, right? And its speed is getting decreased and decreasing, and then at finally the the motion is coming at rest, right? So this is the correct option, because due to friction, amplitude and momentum of oscillation continuously decreases, right? So this graph is showing that the particle is moving, or means the oscillations, the motion of the block is decreasing and at finally coming at rest, right? So this graph, this trajectory best describes the oscillation of the uh, block on the horizontal surface. Okay, so option B is the correct option. Very simple question. If you are conceptually strong, fundamentally strong, you can easily solve these type of questions. Okay, next question. Question number 4. Okay, fourth question is a good question. It's from complex analysis. Okay, question number 4 is, let C be the let the C be the circle C be the circle of radius pi by 4, centered at centered at z equal to 1 by 4 in complex z plane, in the complex z plane that is traversed counter clockwise. Okay, that is traversed that is traversed counterclockwise counterclockwise that is traversed counterclockwise. The value of the contour value of the contour integral value of the contour integral, that is z square upon sine square 4z dz is okay. Options are option A 0, option B I pi square by 4, option C is I pi square by 16, and option D is I pi by 4. Okay, this is the question, guys. Okay, so let's see the circle of radius pi by 4 centered at z equal to 1 by 4. Okay, in the complex z plane, that is traversed in counterclockwise, and the value of the contour integral just we need to find out. Okay, so very good question. I'm going to solve it now. So we have been given fz. Okay, fz is given, that is this one, z square upon sine square z by z, or we can write z upon sine 4z whole square, right? Because this is given z square upon sine square 4z, right? So we can write this like this, because z by sine 4z whole square, right? Now we'll draw the circle first. Okay, so this is going to be like this. This is the origin. Okay, and this is the center of the circle. So this is going to be this is circle. Okay, this, consider this a circle, guys. Okay, it's not looking like circle, but it's a circle, guys. Okay, this is the center, z equal to 1 by 4. Okay, and so this is 1 by 4 distance. Okay, and this one, and c is given, circle is given of radius pi by 4. Okay, radius is pi by 4. So pi by 4 means 1 by 4 means 0.25. Okay, and pi by 4 is that is 3.14 upon 4, so that is almost equal to 0.78 something. Okay, so this is the contour, okay, of radius pi by 4. Okay, so this distance is pi by 4, this is pi by 4. Well, now we'll solve it. First we'll find the poles. Okay, so from here for poles sine 4z is going to be 0, right? Sine 4z equal to 0, right? And we can write sine 4z equal to cos sine n pi. Sine n pi value is 0. So 4z equal to n pi, and z value is equal to n pi by 4. Okay, so from here value of z equal to 0 and pi by 4. There would be other values as well, that is uh, 2 pi by 4, that is going to be pi by 2, right? But these 2 point 0 here and this point pi by 4, pi by 4 means like these will lie inside the contour, okay, and other points will not lie inside the contour, so we don't require those points because we need to find residue. So z equal to 0 and pi by 4 will lie inside the contour, okay. Other values are outside the contour. Now we'll find residue, okay. So for first we find residue we find we'll find residue at z equal to 0, okay. So we have been given function we have, that is z upon function is z upon sine 4z whole square. So we'll open it, okay. So it is going to be z square, and this will open. Sine 4z is 4z minus 4 cube z cube upon 3 factorial plus so on, right? This we know, okay, because we know sine z, if you open it, it's going to be 1, sorry, z minus z cube by 3 plus z5 by 5 plus so on, right? We know it. Okay, so this is the one. Now we'll find this. So this complete whole square, right? The complete whole square, or here we'll write z. So we'll z we'll take z in numerator denominator. So this is going to be 1 upon 4z upon z, that is going to be 4 minus, and this is going to be z will get cancelled by z3 will get z cancels z3 by z2 times, right? So z square times, so this is going to be 4 to the power 3 z square upon 3 factorial plus 1, okay, this one. So here we can see, or we can write 4 minus 4 cube z square upon 3 plus so on to the power minus 1 we can write, okay. My apology, it's minus 2 to its square, right? So minus 2. So we can see here, right, there is no term of 1 upon z, okay. There is no term of 1 upon z because residue is coefficient of 1 upon z, okay, but there is no term of 1 upon z. So that implies residue at z equal to 0 equal to 0, okay. Residue at z equal to 0 is 0, so residue is 0 for z equal to 0. Next we'll find residue. Now we'll find residue at z equal to pi by 4, okay. So this is going to be, again we'll write this term z equal to pi by 4, that implies z plus pi by 4, or we can say we can say z minus pi by 4. This is the right, so we can write like this, z minus pi by 4, we can say it is t, okay. So So now, so it means value of z is going to be, so this implies value of z equal to t plus pi by 4. Okay, now we'll put value of z here at z. At z we'll write t plus pi by 4. So this is going to be it is z upon sine 4z whole square, right? So this is in place of z we'll write this one, t plus pi by 4. So t plus pi by 4 upon sine 4z, 4 into t plus pi by 4 whole square. Okay, and now we'll solve it. So this is going to be, this is going to be, so residue at z equal to, this is going to be, okay, okay, so this is going to be, we'll open it, t plus pi by 4 whole square upon, this is going to be 4 4 will get cancelled, 4, so this is going to be sine, this is going to be sine 40 plus pi, right? This is 40 plus pi, so sine 40 plus pi, I'll write it, sine 4 outside, this is 40 plus pi by 4. Okay, 4 4 will get cancelled, 40 plus pi is uh, minus sine 40, and because there is a whole square, so minus minus plus, so this value is going to be, that implies t plus pi by 4 whole square upon sine 4t. Okay, minus sine 40, but it is going to be sine 40 because sine square 40. Okay, sine square 40. Okay, so this is the square, so or we can write, that implies, we'll open it, t square plus pi square upon 4 pi square plus 16 plus 2t 2t pi by 4. Okay, upon, we can write sine 4t whole square, and write like this. Okay, so again we can write like this, so we'll open it, value of sine, so value of sine 40, we can write like this, we can write here. Okay, this is 4z. Okay, 4z minus, we'll open it, right, 40 means 40 minus 40 minus 4 cube e cube upon 3 factorial plus so on, right, whole square. So this is going to be t square plus pi square by 16 plus 2t, 2 will cancel for 2 times, so this is pi by 4, pi by 2, and this is going to be 4t minus 4 cube t cube 3 factorial so on minus 2, right? And so now what we will do, we'll take uh, this one, so this is going to be minus sine 40. Okay, let's take it. Okay, so now we'll take 40 common. Okay, so we'll take 40 common. Okay, so we can take 40 common here as well. So this is going to be, we have taken 40 common here, 40. Okay, so this is going to be taken 40 common. Going to be 1 minus, because it is 1 minus, and then this we have taken common, so this is going to be 40, that is 40 means 16 t square we have taken common, right? 16 t square common, and this is 4 cube t upon 3 factorial plus 1, right? So now we will calculate it. So t square will get cancelled, okay, and here this is t, so 1 upon t square it is going to be, so this is not, this is t, right? T, okay. So here you can see this is one, because here you can see t, and this is going to be t will t cancel, so pi upon 32, right? So pi upon 32, so this is going to be pi upon 32 t, pi upon 32 t, okay. This value is going to be pi upon 32 t. How? Because t square will get cancelled, so this is going to be 1 upon 16. This is there is no t, so this is going to be pi square upon 16 into 16 t square, but we need only the coefficient of 1 upon t, right? That tells the that is the residue, and here you can see we will multiply by 1, right? And then these values are not going to give 1 upon t, right? And so here you can see this, you can check it here. So this is going to be pi, and dt will be get cancelled, so pi by 32. So this is the residue at x equal to pi by 4, okay. So 32 t, so coefficient of t, so residue is pi by 32, okay. So now we know the integration value, right? How to find out, right? So this is going to be integration value. So integration I, that is closed integration z square upon sine square 4z dz is going to be 2 anticlockwise, right? 2 pi I sum of residue, and this is going to be 2 pi I residue at z equal to 0 is 0, and this is pi by 32. So this is going to be I pi square upon 16. This is the answer. I pi square upon 16. And which option is matching? Okay, which option is matching? Option C. Option C. I pi square upon 16. Okay. Okay, guys. So before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes, which are going to help you to crack the exams related to physical science. Okay. Okay, guys. Bye now.